Hello and welcome back to Doodles MD. I am Folake Lawal, your public health, infectious disease and internal medicine physician. This week we're going to continue from where we stopped last week, which is about the immune system. So last week we had introduced the immune system, talked about the three different types, and gave a little intro about them. And then last week we also talked about the innate immune system, which is the first one of the three we described. And this week we're going to be talking about the second one, which is passive immunity. Now, with innate immune system, remember we talked about that we have innate, we have passive, we have active. And innate is what we're born with, which are natural defenses that are not just with immune cells, but it also comes with physical presence like the skin, tears, mucus that's secreted. Also, we have the chemical forms of it, where the body either uses acid or mucus or tears or fluid to be able to neutralize in terms of enzymes, neutralize, destroy, or just wash away things. And lastly, we talked about having actual cells that are general responders, and then they respond to an attack, they try to control it, they send information to the engine room, so to speak, to produce specific things to be able to clear that infection. So, like I said, this week we're going to be talking about passive immunity. Stay tuned. Okay, so the next part I'm going to talk about is passive immunity. Remember when I said active immunity, your body is reacting to something, it is making specific targets and laser focused destroyers to something bad. Passive immunity is taking what somebody else has done and giving it to someone who cannot do for themselves. So we use passive immunity in different ways. One, it can occur naturally, and it can also be artificial. Natural is mother to child. And that's why, when we're talking about maternal health and global health, this is why maternal health is very, very important, because it helps in the first year of life of the mother. If a mother is malnourished, she cannot produce enough antibodies and protective agents to give to the child. So in transfer from the placenta in the third trimester, which is why, again, preemies can get very sick. In the third trimester, mostly, the mother is able to pass on specific antibodies. In humans, it's mostly IgG. It's the least heaviest. It's one of the smaller ones, and it's the one that lasts long in the body. So I could get an infection, and like when I was young, and you might still find it when I'm older. That's usually IgG that you find there. So the mother in the third trimester through the placenta passes IgG to the baby, right? And these antibodies or immunoglobulins are able to protect the child up till 1 year. Up till 1 year for diseases like tetanus. That's why it's mandated that pregnant women get tetanus shots. For tetanus, for things like diphtheria, before a baby is born. Also, breast milk. We know about colostrum, we know about breast milk. This one produces IgA, right? And IgA is specifically for mucous membranes. So the mouth down to the gut, and then the nose down into the respiratory tract, and down the ureters that join the kidneys, down to the bladder, and down through the pee hole, right? Those are the mucous membranes, and the IgA protects them. They serve as, additional layer of the antibodies or the defense on that level. So when something comes, they identify the bacteria and they just clamp onto it, prevent it from using its arms and its legs to attach to other things and penetrate the body, and they neutralize it and go. So the breast milk also produces that. And the good thing is the breast milk is able to adapt, because when a child is nursing directly, the cells around the milk hole can pick up on the infection. If a child has a little cold here and there, the cells can also pick up on that, and they are reacting like, oof, there's something in this saliva that this child is putting here. And mothers who have breastfed or people who are in that field will tell you that the color of the breast milk actually changes when the child is not feeling well, and sometimes it becomes thicker, sometimes it's grayish, and whatever, depending on what is produced and what the child needs. Okay, now that is natural passive immunity, where you're giving to the child. Now artificial can come in multiple ways. Artificial really is, again, like we said, someone who they used to take from animals like horses, or from people who have recovered from a certain illness, and give it to someone who is newly ill for that. And that used to be very common in the 1920s for a lot of bacterial infections, before we had really lovely antibiotics and even some vaccines. So they would take somebody's blood and separate the blood cells from the fluid of the blood, which is the plasma or the serum, and infuse that into human beings. And we still do that today. In the COVID time, I'm sure you've heard about things like, plasmapheresis, plasma infusion. They're giving somebody plasma. That is passive immunity. You're taking the immune action that somebody else has created and giving it to another person. And this can also be in form of concentrated immunoglobulins, where you really distill down and separate different parts of the blood. So you take out the blood cells, then you take the serum or the plasma, and then you separate the proteins that are antibodies, and then you bring that together as immunoglobulin. And there's some people who have abnormalities or diseases where they cannot produce either certain types or all types of immunoglobulin. So people have hypogammaglobulinemia, they have combined common variable immune deficiency disease, all of these kind of things. And some people have to get weekly immunoglobulin shots or monthly immunoglobulin shots to be able to stay alive and fight infections and not fall ill. So this is part of the artificial. Another form is, what we call, you might have heard of antisera. So maybe you get a punctured by a rusted nail, right? Or somebody gets bitten by a dog. Artificial immunity is part of what we use, where they say, the wound is dirty. They give you a tetanus vaccine in a separate site, and then around that wound you get injections for the tetanus immunoglobulin to try and neutralize, because they're neutralizers, right? They're neutralizers, and to try and neutralize the spores or the bacteria or whatever it is that's around there. Same for rabies. They give them on different sites so that the one you are trying to stimulate and the neutralizer, they don't come together. So they give them in different parts of the body. Now, one very interesting thing is, as technology has advanced, this artificial immunity is what has now evolved into the use of medications that are monoclonal antibodies. We've been able to precisely now select out, this is the antibody that either neutralizes this thing or neutralizes that thing, especially in autoimmune diseases where your body's turning against itself. And we'll talk a little bit about that, because there are parts of the body, when I talked about things attacking your body, attacking a cell that it feels it's compromised. The same way your body can produce attackers against parts of its own body, because it sees it for some reason, different reasons, that it's compromised, right? And so you can create neutralizers against the attackers that your body has created against yourself. It's complicated. It's kind of like a tripod, but yeah. Anyway, so I'm going to put a pin in it for today, and next week we're going to talk about the active/adaptive immunity. I hope this was informative in one way or the other, and I hope you enjoyed it. Please like the video, share it with your friends, and subscribe to our YouTube channel. Follow us on our other social media handles. Until next week, I am Folake Lawal on Doodles MD. See you again. Bye.